Homework 6 is on graphing parabolas. So we're going to start with, we're going to do number 3. I want to make sure that we end up with one that's vertical and one that's horizontal. All right, so we have our standard form. This one's already basically in the standard form. We're going to go through our step-by-step process, which is starting by making sure that it's in the form that it's in. So you can see you've got the x term squared, the 4 times p, and then the y minus k over here. So that's the standard form. Next, as part of that step, is to determine the type of parabola that it is. So if it's in this form where you have the x term squared, that is a vertical parabola. It either opens up or down. Okay, so start by determining the type that it is. That's just almost more for you. It's just to know what it's supposed to look like. So it's either going to be up or down. Next, you want to find and graph the center, which is HK, the center or the vertex. Those two can be used interchangeably. So this one, you've got a positive 2 for x, and that will make this a negative 4 for y. This one, since it's vertical, the x naturally comes first. Make sure if the y is the one that comes first, that you're writing the terms in the proper order for the vertex. All right, so since this is a vertical, the axis of symmetry goes right down the middle of the x value. So this would be x equals 2. All right, so we're going to start at 2 and then down at negative 4. And you're going to have this dotted line, this vertex, or I'm sorry, this axis of symmetry running right down through your vertex. So you start with that information. Next, you want to solve for P to determine the direction of opening. So you need P in order to graph the focus, and you also need to solve for P in order to determine whether your graph is going to go up or down, because the focus is going to go one way, the directrix is going to go the other way, and you need to know which one. So this value right here, 6, remember that formula is 4P, so you can start by saying 6 is equal to 4p, and then divide both sides by 4. So 6 divided by 4 reduces down to 3/2 or 1.5, whichever you prefer. The important part is, since p is a positive value, this graph is going to open up. All right, so based on this value, we know that our graph is going to open up. We know that. Then we can use the value of p to graph the focus and the directrix. So since it opens up rather than down, we can go up 1.5 units. So that point right there is going to be the focus. We can go down 1.5 units, and this is going to be the directrix. Okay, so we've got all that information. Remember, the axis of symmetry is always going to be perpendicular to the directrix, so we've got that information so far. The focus and the directrix, the entire purpose of those, remember, is that every point on the parabola is equidistant from those two. Okay, so from the focus itself and from a point on the directrix. So this obviously is equidistant when they're all lined up like this. It's a 1.5 in each direction. So we use this sameness, this equidistant property, in order to plot more points on our parabola. So the idea is, if you kind of go parallel to where the actual focus is, then you can find another point. Because since it opens up, you're going to have another point that shares the same y value. So you can either literally plug in the y value, that will work, or you can use this, like I said, this equidistant property, knowing that this is 3 units away, like the 3/2, this is 1.5, this is 1.5, so this is 3 units away, the focus from the directrix. So if I go 3 units this way, then my point would be 3 units to the right of the focus, which would make it 3 units above the directrix, and that means it must be on the parabola if it's equidistant from the focus and the directrix. So we can automatically go up to where the focus is, and since this distance is 3 units, I can go 1, 2, 3 units over here. All right, so you can see this is another point on the parabola. It is equidistant from the directrix and from the focus. And then I can use my symmetry to go 1, 2, 3, back in the other direction there, and now I have 3 points. I can connect the dots and make my parabola like this. Let's write down the rest of the information. So the focus is an ordered pair, and it is 1.5 units up from where the vertex was. So this still shares the exact same x value, but it's 1.5 units up. So if we started at negative 4, it ends it up at negative 2.5. And then the directrix is a horizontal line, and it is 1.5 units down from where the vertex was. So the vertex had a value of negative 4, So we are down at -5.5. You can use decimals, you can use fractions, whichever method you are more comfortable with is totally fine. So you could have used, -5 halves for this and -11 halves for this, and that would work just fine as well. All right, so that was a vertical one. I want to make sure we're doing an example of a horizontal one as well. And let's do one that we have to get into standard form ourselves. So let's do number 7. All right, so number 7, we're going to start by making sure that we use our completing the square properties to get this into standard form. So we're going to start by gathering the y squared plus 10y stuff. By the way, as soon as you see a y squared, you automatically know that that is going to be a horizontal parabola, so it's either going to open left or right. So we're going to gather the y stuff on the left. We are going to subtract the 4x and subtract the 33 over to the right-hand side, because that's eventually going to be your 4p times x minus k side. So on this side, we're going to start by completing the square. So we are going to use this middle term right here. We're going to cut it in half, and then we're going to square it, and that gives us 25. So that's the value that we can add to both sides. So we can turn that left-hand side into a perfect square trinomial to get it into our standard form. Okay, so when I add 25 to this right-hand side, I have -33, and then I add 25 to that, so that comes out to be -8. All right, so next 2 steps, you can do this in just one move. So this you want to factor down. So multiplying to 25 and adding to 10 would be +5 and +5, so we write it as our perfect square trinomial. On the right-hand side here, whatever this number is should be factored out. So divide out a -4, this is an x, and then this is +2. So that is what we should have written for our standard form. Okay, so knowing this, we talked about it being horizontal, it's either going to open left and right. It's either going to open left or right. So now that we have this, the first thing we want is the vertex. Remember I mentioned on the previous problem, make sure you're writing it in the correct order. So -2 would be the x value, -5 would be the y value. The axis of symmetry, since it's horizontal, is now a y equals line. So we pair it with the y value from the vertex, and then we'll figure out what the value of p is, so we can figure out which direction it opens, what's the focus, what's the directrix, and we'll plot everything from there. So this -4 is supposed to be equal to 4p. So if I divide both sides by that 4, then we figure out that p is equal to a -1. And since that value is negative, that means that this parabola is going to open to the left. Okay, so let's start graphing what we have so far. So -2, -5 is the vertex or the center of our parabola. And so this is going to be our axis of symmetry. Since our graph opens to the left, we know it's going to look like this. So the focus goes left, the directrix goes right. So the focus goes 1 point to the left. The directrix goes 1 unit to the right. So this point right here, the focus goes 1 point left. So 1 point left of this would be -3, but matching the y value. And then the directrix is an actual x equals line, because remember it's perpendicular to the axis of symmetry, and it goes 1 unit right. So it goes from -2 back to -1. So you've got that. Remember, you need your second and third point though. So we use this idea that we talked about on the front, where anything on the parabola is equidistant from the focus and the directrix. So the focus and the directrix are 2 units apart. So if I go 2 units in either direction from the focus, this must be on the parabola, and this must be on the parabola, because it's 2 units from the focus and 2 units from the directrix. So use those 3 points and plot your parabola.